Okay, so welcome once again. Sorry, let me share my screen. Okay, let me share my screen 1 minute. Yeah, here we go. So remember, these are the things that we were talking about, and we had covered this last time. You remember about the HIV gender? We did the cleaning. We started doing the plots, and remember that question you have seen that has had labs. So let me just run first of all everything so that we can load everything nicely. Then remember what we said about the Dodge. Remember, do you see that position equals to Dodge? It actually ensures that the grouped bars are actually plotted side by side, and that's why the answer was C. Also for the labs, you see how we define the labs. The labels is plus the labs x equals to age groups, y equals to count. That's how we put the labels on a given plot. Okay, if you want to put the title, you can still include it as an option inside the labs. So title equals to HIV, and that's why you can see in this plot, HIV status by gender appears as the title. Okay, we also saw how to make size of the points, different size of the points. You pass them as arguments. How you can change the transparency or opaqueness of those points in the plots. We also saw that these colors can actually be set by a static value where you actually define the color explicitly, or it can be scaled to what we call column values of the data, where you let the data define the color that is going to appear to those points. All this we did last time. You can also add trend lines. We'll look at it again shortly in another example. LM means for a linear model, and that's why on plotting this, we actually saw that you could get a straight line that is black and the size is 0.5. I'm actually running line 117 to 124. That is black in color. Okay. This is also another thing we can add here. SE, if you write SE and you say false, what this does, it just removes these bounds, the confidence intervals in that plot, and just leaves you with just the line only. Okay. I can see there's a question in the chat. I already shared. I think Azumani will share the script with you, but I already shared with our technical team to share with you. So Frank, don't worry, you get the script after this. Then the other thing, okay, please note about this. This is just more arguments that you can add to alpha. And as I've said, you can always check on the cheat sheets that we have online or a ggplot2 website. There's so many things that you can add to this, so many options that you can add, but you may find that some of them are not really that useful. Okay, but that will actually depend on the user. Then remember what we did about the facet grids. Facet grids like this one, whereby we are doing the histogram and the bin width equals to 5. But then we said that we want the facet grid to be HIV and HIV gender and category. Remember, this tilde has to be there inside the facet grid. So in this case, we'll have a plot that will have subplots that in the columns we have can have category and gender. Let's see. We can run this. You can now see what we have on the as our columns. We have the HIV category here. You see. Then on our as our rows, what we have is HIV gender. So remember, Frank, that we use facet grids to create subplots of variable data. Okay, that's why we were able to create subplots for a HIV gender and HIV category. Okay. Code Cartesian. Now, let me mention something here. It is possible that we just use a y lim equals to like that and do away with this one here. The reason why this is not advised that you just use when you're setting the coordinates of an axis, that you just use y lim equals to c. You pass the vector 0, the starting value up to the end value, is that this sometimes actually cuts or leaves out some of the data points. And the better way to do this is by using this value inside inside the function that is called the Cartesian plane. If you do this, what you're doing in line 31, the code Cartesian, then you pass the limits of your axis. This one ensures that data points are not cut out, okay? So always remember that in ggplot2, as long as you want to have user-defined axis, define those limits, x lim, y lim, inside this function called code Cartesian. This helps a lot because it does not cut out at the data points, okay? Then as always, the lab title, inside the labs, you can define the title of the plot. You can define the x-axis now. The way it has been done here in this plot is that it has just taken it from the data, but now you can define these labels on your own, okay? We can also have, and remember, a facet grid I said is for 2 dimensions, but now a facet trap, you just need to pass one variable, and that will just give you a side-by-side plot of gender. In this case, the columns are gender. But now, let us have this HIV gender. Let us have it before the tilde, and you see what happens. Remember, what we have plotted, will it be possible? No, it should not be possible. Something I'm confusing this. Okay. Yeah. So that is the facet grid. So, but if you'd like to flip the code and have it the way it was, you can just remove this. You can code flip. Basically, what is doing, it just flips the charts so that instead of having it this way, you can have it looking the horizontal way. That's the function of that code flip. But these are just options. It's a ggplot that you may find useful or not. Theme. Remember, we said that how to change the overall theme of a given plot, we just use the theme underscore set. In this case, it's just black and white. In the next plot, you can see it's gray and etc. Okay, they're just options to actually improve the way your plots actually look like. Then this is still a facet trap, and in this case now the colors have been defined manually. Do you see this? We are now defining the colors manually. So if you run this, and I've defined the colors as, I would like the colors to be C. Number one should be forest green, and the other one to be fire. There are so many colors and so many variations and their names. Because it's a color even I've never heard of, fire brick 4. Okay, fire brick 4. So that's also another color you can actually use. Then you can also do the labels, the facet trap, and such kind of things. Now, let me check on. Okay, see, there's a question in the chat. Short link. Okay, so let me see. So there's one we want to do. Frank is asking how to interpret these graphs. Do you be the violin plot, Frank?
Yes. Yeah.
Okay. The violin plot. these ones are just are basically trying to show the distribution of that data. Okay, and I would like you to think in the lines of a box plot. Okay, where you will have outliers on the extreme ends of that chart. Then you'll have where you actually tend to have the mean or the median, you'll have it bulging. Okay. Then towards let me just let's just have it as a plot. You see. So you see this point here, uh, this point, which is I think is about 5,000 here. You can think of this as the extreme points or the outliers. Then the places where it is actually budging, this is where you have more data points, and this can imply this region is where the median is in this case. Okay, so what this plot is also doing is exactly just trying to show the probability distribution of this numeric data. Okay. I don't know whether that's okay, Frank.
Yes, it's okay. Thank you.
Okay. Then now, on top of this, what we did last week, I would also like to add something else, which we can actually try to do together. We just want to add some more aesthetics to our graph. We can just do it together. So in this case, I would like to do, let's do this. I would like us just to do more on aesthetics. More on aesthetics. So what I want to do, I would like us to do a ggplot. Oh, sorry. I'd like us to do a ggplot. A ggplot of, we're going to still going to use our HIV data. HIV data. Then I can do IS, or rather, let me do what we're actually having in that quiz where we were doing mapping equals to IS. So in this case, I want my X to be the CD4 count. Then my Y to be viral load. Then I would like the color to be determined by the color equals to HIV cut. Okay. So I've defined my aesthetics, but now what do I actually want? Oh, thank you so much, Azmani. Frank, Ajibola, and Mema, he has actually shared the R script that we are using. So you can download it there and just for reference. So in this case, but this part which I'm starting on line 153, it's not in the script. So you can just consider doing it. So in this case, ggplot, so I've defined my data, the X and Y axis and what I want the color. So this is what we're calling setting the color by column values or by the data. Okay. Then what do I want to do? I just want to add a geom point. And you can see, once you just write the word geom, you can see the number of geometrics that you can actually do. There's so many, so many that you can do. So I want just a geom point. Then let's just run this first and we'll see what it actually gives us. So if we run it, you can see it has given me a geom point that has the positive values and negative. Okay. So because you're looking at the viral load, you're not likely to see the pink ones which are negative because the viral load is for you see these values for person who's HIV positive. Okay, but now the main idea of this is that I wanted us to add more aesthetics, like the size. I would like to define it to be equal to 1, just the size of the points. Then we can also have alpha, which would be the transparency. You can say something like 0.6, for example. Let's see. If we run this, what does this give us? So it is the same plot, but it has become, the transparency is actually at the value 0.6, and the size equals to 1. Okay. Now, let us do more. I would like to also add a trend line in this. So I can say plus, and remember how we add the trend line. You can use geom, smooth. And now if you just click smooth, you can see that you must define the method that you want to use the smooth. Okay. So in this case, we can do smooth method equals to, now we have LM, which actually means just linear model. That's how to do the fitting or the regression. But there are others which you can use. Some of the others you can use is what is called the GLM. I'll just post the options here. You can use LOS. LOS, which means it can mean local polynomial regression. Is actually better than LM. Or what we call, you can also have GAM, which is called a generalized additive methods. These are just complicated numerical fitting techniques, but they are very powerful. Then you can also have, I've said LOS, GLM. We're currently using LM and GAM. Okay. Then, so GAM, yes. So that is one of the options. But remember, if you would like to not see the confidence intervals, okay, first of all, let me just run it without the, I have to put a comma there. Let me just run it first of all without, so you can see it is a straight line that shows that as the CD4 count increases, also the viral load decreases. So I can decide SE equals to false. If I do this, what it means that, as I shown you earlier, I want to remove that confidence interval. So what I just have is just a straight line. Now, that is for the linear model. Suppose we just try for the lowest, and we see what does this look like? So you can see for lowest, what it is doing, it is actually trying to, it's for lowest, the other name for lowest is actually locally estimated scatter plot smoothing. So this one looks at short intervals of that data and tries to do the fitting in small portions of that data. And that's why you can see it tries to actually mimic how the data distribution is. So just for argument's sake, let us SCE be true, like that. How would the plot look like? Because you also want to have the confidence intervals. So you can see you also have the confidence intervals along that lowest line. So you can try the rest. You can try GLM. You can also try GAM, and you see what it gives you. So this again stresses the point that ggplot is a layered plot. So you can see that on top of geom plot, or the geom point, we have been able to add a geom smooth on top of it. Okay, so that's a layered plot. Now I can, inside here, I can also add the size of the line. So I can say maybe in this case it should be 1.6 or 1.7 equals to, not equals to that. So let's see whether that one increases or not. There's something that you have left, or rather, okay, let's see. Maybe it can be the issue of the ordering. Let's put it there, and we see. SE equals to Q. Oh, there's a comma missing there. Okay. Yes, you can see now the size has become bigger. So that's also what I was saying. Please remember that the order of the arguments matters a lot, because you see, me defining the size after SE, the argument SE, it was giving me an error. So that order of arguments into these functions must be maintained. Okay. Now we have added a trend line so that you can see how the CD4 count and the variable load vary with respect to each other. Now, the other thing that we were talking about is that in this case now, we can also add the theme. Okay. In this case, I can say I would like the theme to be black and there's so many. You see now, once I've just written the theme and the underscore, we now have so many options for us to choose from. Okay. So in this case, I can choose let's choose dark. Just for argument's sake. Let's choose dark and see what we have. Oh, you can see that one now is becoming dark. That's not really good for presentation unless your background is we can use a black and white, and you see black and white is better. It's better because it has given us a much brighter background. The other thing I would like us to add, besides just having the theme, is to add the coordinate, the code underscore Cartesian. Yes, just the first one. Then I was saying xlim. What do you want our x limits to be? So in this case, let us start from 250, just for argument's sake, and we end at 750. Then what we have for ylim equals to c. C equals to, maybe I can start with that 1500, 1500, and we want to end this at 4000 because yeah, let's just end it at 4000 and you see what actually happens to this. So if we run this, what do we have? Will our graph change? Yes, it has changed, because what has actually happened now, it has actually set the limits to be from 250 on the x-axis up to 750. But our y limits have started is from 1500 up to 4000. I would like us to increase, to reduce this limit to be something like maybe even 800. But for this one, we increase it to maybe something like 5000. And we see, so this one will just depend on the kind of plot that you have. Okay. You can just play around with this aspect of the aesthetics and see what we have. So we've added a trend line, we've added the theme, we've added the coordinate points. Something else is remaining. And what is remaining is actually what we call the labels. Okay. Now we can decide to do the labels this way. Do you see this way? We're doing it here. We can decide to do it this way, whereby we just add labs equals to title, CD4 count plus viral load, like that. Okay. And if we run this will actually give us, the name. The x-axis becomes the CD4 count, y-axis becomes the viral load, and the title becomes a CD4 count versus the viral load. Okay. But now there's a better way that we can also do this again. I will remove this. There's a better way that you can do this. And this actually is from, we can do it within what is called the theme function. Do you see this one? And you can see, just after writing the theme, just before you write the underscore, because the underscore now will give you the other themes that we know for the background. All these that you see here, axis title X, axis title Y, all this can now actually be edited inside the theme function. Okay, let's try. So the theme remember, as you've seen, now it has so many things. Okay, what we can do, just for argument's sake, let us look at the options that it has. Let's look at, oh, I want us to look at help, but it's okay. So let's just go with theme. See, just look at this. If I do F1, you can see that the theme function takes all these arguments. You can have the line, you can have the text, you can have the title, aspect ratio. Do you see on my bottom right pane? You can have the title X, you can have all this, you can define the text size, you can have the ticks, you can have all this. So many arguments that can actually help you to put more options into the plot and have it the way you want. Okay, so many of these. Okay, a lot of this, and you can just look at them. So, for example, we can just go back here in our plot. So we go to the theme. So inside the theme, what we want to do is that we would like first of all to label our axis. So how do you label your axis? If I go here, oh, there are so many options, but I'll just show you quickly. I can come here and say axis dot title dot x equals to, now for this one, you have to define element, what you call element color, and you can see the option actually comes into play. So element underscore text, because that's what we want to edit, text. Then what do you want to edit now? We would like the color to be something like red, for example. This now gives you the option of editing so much in that plot. Then the other thing you can do, you can also decide the size. You can say the size, I want the size of that label to be something like size 15, for example. Okay. Then once you're done with that, you can still come here and put the other thing. What do I also want to edit? I also want to edit the y-axis. So I can just copy. The only thing which will change will be this argument here. I can just copy that, have it here. The only thing which will change here, I can just come and define this as y, and it's supposed to be axis, not axis like that. Axis. And this one, because you're still not yet done, axis like that. Okay. So axis title.y equals to let's change this just for, we can have this as maybe something like will magenta appear? Yes, magenta, something like that. Okay. Let's see, just by running this, how our plot now looks like. Okay. We're just adding more aesthetics to our plot. You can see now what has actually happened is that within this theme function, I can now have my x-axis, which I had labeled earlier as is CD4 from the data. Then I can have this as size in red color, the y-axis in magenta. Then the sizes can be 15. What else can we do with this? This is the title, okay? But now I can still also add the size of the text. Sorry, this was the size of the label. Now we can add the title, the size dot text dot x. So you can have a element texts. This one here. Okay, element text there. What do I want? I just, for this one, I can just define the size. Let's say it's 30. I want, yes, I know I've made the label to be red, but now and the size of the label is 15, but now I want it to be 30. What happens after this? Okay. You can also do the same just for uniformity. You can also do the X. You can carry the X axis there. What do you want to do? The only thing you can change in this case is Y, because now we want to do the Y axis. Size, maybe you can just, let's put it at 20, for example. Okay. Let's see what has this done to our plot now. So this one, if you run now, you can see that the text or the Y-axis now, like the 30, 450, 500, 600, and 700, what it has done, that has actually been increased by size 30. Okay. But what we have on the Y-axis, that one has been increased to size 20. Okay. So the first two options, line 165 and 166, that gives you the option of the labels, the title of the X-axis, title of the Y-axis. You can do any editing that you want there concerning the title of the titles of the labels or the axis. Okay. But now for the text of the axis, or the text that actually signifies the variables, like the numeric variables on the axis, that one can also be changed by using axis text dot X axis. Okay. Then you can ask yourself, can you change the type of the font? Yes, it's possible to change the size of the font. So for example, okay, we'll see this shortly. Then other things that you can add is the legend title. Legend dot title. Is it appearing? Yes, this one here, legend dot title. You can also add it again. So you can have, you may want to say that I want element. What do I want about concerning the legend? I would like to change the text. And in this case, I can just say the size equals to maybe 25. I just want it to be as large as possible. What else can we do there? Now, when it comes to the legend, we can also change the text. Do you see this negative and positive? We can change the size of that text. So you can have legend to text. It has come. So again, we want to do element, element underscore text, like that. Then we can also do the size. Maybe the size to be something like maybe 18 or so, but it just depends on how aesthetically pleasing it will be. When it comes to the legend, the other thing is that we can also define the position. And the position is defined by X-axis and the Y-axis. So you can say legend dot position. Where do I want it to be? I want it to be at position 1, maybe at 0.5. We have added a couple of things for the legend. You can also add justification. So you can add legend dot justification. You can also justify this depending on the values that you actually define. Okay. Let's see so far what has actually happened to our legend. Please take note of how it is looking right now. HIV.cat, you can see negative and positive. So if you run this, what has actually happened? It has increased the size of the legend. First of all, the text has been increased. The justification and also the position. Okay. Just for argument's sake, let us change this to be something like 0.5 and 0.5 for the position. 0.5 and 0.5. What does this actually give us? So if you do this, you can see that it's now somewhere in between, but this is not what we want. Suppose, let us also change the justification and we see what actually happens. 0.5 for justification. Justification. So there's a way that that text is being adjusted. Okay. So these are just part of the options that you can see or that you can use. One, let's do this at 100%. So go to 1, and this to be also at 1, or rather 1.5. We see what happens. If you run this, yeah, it has disappeared. It's somewhere just beyond our axis. So we need to reduce that value, maybe to 0.5 the way it was, or maybe 0.8. So if we do this, that becomes something like that. Okay. So it's just a matter of you changing the values of x and y. So 1 becoming the x, 0.8 becoming the value of y. Okay. And you can think of this in terms of percentages. If it's 1 is like 100% of that axis, and etc. Okay. So we can also have other things that we can add in this case. So let's look at how about titles? We can also add plot. We can add plot.title. You can see just when I write the plot inside that dim function, it immediately prompts me to add the plot title. I can also do element text. This has to do with a lot of editing of the text that comes on the chart. So I can say I would like the color of that to be, which color can we use now? Maybe cyan. Yes, you can use cyan. Then I would also want it the size of that plot title to be something like maybe 23. But there's other things that you can also do. You can also add the family of fonts that you want. Okay, you can also add the family of fonts. So in this case, I can use Korea. You can also do sans serif. You can do Times Roman and all those. Okay, if I use Korea, then what do I want to do now? I can now put the GG title. I know you saw this in the quiz. So this is how now you can do it. So CD4 versus VL. This is something that now we can check and see how the plot now will look like. Error in okay. I did not put a comma there. So that's okay. So you can see now, these are just part of the options that that you can add to improve the appearance of the plot that you have. Okay, wonderful way within the theme. Just beside the options that you have for ggplot, you can also do inside the theme. And the theme, inside the theme function, it actually gives you more control of how you can improve the appearance of the chart. Okay, and these values here are user defined, so you can have any values that you want. You can have any type of font you want, any family of font, any color, any position of the legend that you would like to have, the type of the axis labels, how you want the family of fonts to be, and etc. Okay, that gives you more option of actually editing and improving the aesthetics of your plot. Okay, and as I said, inside this theme function, okay, inside the theme function, there's so much you can do. Okay, all these are just values that that can actually be added. Okay, can actually be added to this. Okay, but it will just depend on what you want to do. Okay, I don't know if there's any question. So please take note that from line 153 to 174, these ones are not in the script that was sent, but it's something that you can now do for practice. Okay. You can do for practice, just try do the exercises, try to do. And now, I would like to shift to something which I shared on the Art for Fun Club. So I don't know, first of all, if there's anyone with a question on this. It was just a review of what we did, plus more on using the theme function. So we have seen facet trap, facet grid, using the theme function to improve the aesthetics of the plot. I think that's what we intended to cover today. Something else that let me stop sharing and I share my, just 1 minute. Yes, I had shared something. I had shared something on the Art for Fun Club. If you have time, please go and look at it. Then we will start with it next time during the class, next week. I had shared this about 4 days ago. I don't know whether any one of you tried. So this one, it was just something to do for fun. So it was in a bid to understand the relationship between ice cream sales and UFO sightings. The following plot was obtained using ggplot2, using the code below. And the plot looked like this. I don't know whether you tried looking at it, but the plot looked like this. So where you have ice cream sales, daily temperature here. You have the legend here, UFO sightings here, the seasons here as part of the plot, the autumn, spring, summer, winter. You have your titles here. Do UFO sightings increase with hotter days and more ice cream? Then there's another title there, a whimsical exploration of UFO sightings and ice cream sales life. So just something to try, but the task that I wanted you to do there, I had pasted the ggplot for that function. I wanted you to look at, I wanted to look at and fill in the missing parts. Like in this part here, how many missing parts we have? 1, 2, 3, 4, 5, 6, 7. Try to look at the plot. Just by looking at the plot, I know you can get what is missing. But come next week during the class, we will start with this example. I'll take you through this example. Okay. So otherwise, I would like to stop there for today. Then we will meet next week on Thursday for the other session of, we'll start with it next time during the class next week. Otherwise, I wish you happy practice and see you next week. Bye.